If you had an equation like this, expression, 1 plus x all squared, you would be able to expand that, right? It's quadratic, it's pretty straightforward. If you had something like this, a cubic function, you can still expand that because it's relatively straightforward. Let's say you had something like this, where it's to the power of 6. That would take you forever to do. It would take a really long time, and it would very easily get really confusing. So in something like this, where you have a high power, in order to expand it, you can use the binomial expansion. That's the whole point of it. Now, the binomial expansion is a very easy to follow and use formula. It's just a really long formula, but it's definitely worth remembering. And when you answer questions and you start to apply it more, you're going to find yourself using it quite quickly and not even thinking twice about the general equation. But the binomial expansion is as follows. A plus b in brackets to the power of n. A can be any number, b can be any number or letter, n can be any number. N will always be a number though. It won't ever be a letter. So you're going to take your first term in your bracket, a, you're going to do that to the power of n. Then you're going to add, and then n1, a to the power of n minus 1 times b. Okay, that n1 stuff is a little confusing. So if you have a look at your calculator and you have a look at the divide button on your calculator, just above it, between the divide button and the AC button, you're going to see a button NCR, or you're going to see that label, right? In order to press NCR, you need to press shift and then divide, and it will come up with that C. Now, NCR is a way for you to expand NR notation. Okay? NR, so if I take this a step further, this makes use of something called factorials. So if you have a look at the x to the power of minus 1 button, just above that, you're going to see the x and then an exclamation mark. So if you press shift and then that x to the power minus 1 button, you're going to get an exclamation mark. The NCR basically condenses n factorial, and that's what we call this exclamation. We call it factorial. And then r factorial times n minus r factorial. That's really confusing. Let me explain what that means. Suppose if I have 2 factorial, that means 2 times 1. If I have 4 factorial, that's 4 times 3 times 2 times 1. Okay, so 5 factorial is going to be 5 times 4 times 3 times 2 times 1. Okay, you get the point. Now, if I have 3, 2 in brackets like this, making use of that NR notation, using that factorial fraction, this would be 3 times 2 times 1, all divided by 2 times 1, times by 1. Yeah? Okay. Let's say if I had 5 over, no, not over, 5, 3. This would be 5 times 4 times 3 times 2 times 1, which is my n factorial, over my r factorial, 3 times 2 times 1, and then multiplied by n minus r, which is 2, factorial, 2 times 1. Do you see how this is quite long? And when you have really large numbers, that's going to get even more confusing. So we can condense that fraction with all the multiply signs using the C notation. That's the whole point. That's why we do it. So if you were to plug in your calculator, all of this, it would be the same as plugging in your calculator 5C3. You would get the exact same number. Now let me show you how to do 5C3. In your calculator, I want you to AC everything, press the number 5, shift, divide. Now the C has come up, and then 3, and then press equals. So you get 10. Does that make sense? Okay, going back to the binomial expansion, now that you understand what the NR notation is, your first term is a to the power of n, then n1, a to the power of n minus 1, multiplied by b. And then n2, a to the power of n minus 2, b squared. And that will continue until you have nr, a to the power of n minus r, b to the power of r, plus, and then b to the power of n. That's going to be the last term. Okay, that was long and a little confusing. But once I take you through an example, you're going to find that it's actually relatively easy. So the example that we're going to do is 3 minus 2x to the power of 5. This is following the a plus b to the power of n format. Our a is 3, our b is minus 2x, and our n is 5. Our binomial starts with a to the power of n, so 3 to the power of 5. We're going to add the n1, so 5, 1, with our a to the power of n minus 1, so 3 to the power of 4, times by b, minus 2x. Does that make sense? Okay, let's take our binomial. Let's copy it over here just so we have it to refer to. Okay, so this was our a to the power of n. This was our second term. Our next term is going to be this. n2, so 5, 2, a to the power of n minus 2, 3 to the power of 5 minus 2, which is 3, and then b squared minus 2x squared. Okay, the next term, 5, 3. 3 to the power of, or a to the power of n minus 3. We did n minus 1, we did n minus 2, now it's n minus 3 squared. And then we did b squared, now we're going to do b cubed, minus 2x cubed. Do you see where this is going? It's just doing consecutive stuff. Okay, so the next one, 5, 4, 3 times minus 2x to the power of 4. And then lastly, we're going to have minus 2x to the power of 5. 3 to the power of 0 gives us 1. So that cancels out. That's no longer there. And 5, put it in your calculator. Put in 5c5. What does that give you? That gives you 1 as well. 3 to the power of 0 gives you 1. So it's like doing 1 times 1 times minus 2x to the power of 5. We're not going to write the ones. So that is our final term, minus 2x to the power of 5. So it's quite long. I hope you can still see it. That is our full binomial. Now it's just a matter of plugging it in the calculator. So let's do it. Type in 3 to the power of 5 in your calculator. What do you get? 243. Next, I want you to do it periodically. I want you to break it up. First, work out 5(1). So 5c1 is just 5. 3 to the power of 4 to the power of 4 is 81. And then minus 2x. 5 times 81 times minus 2 gives us minus 810. Let me switch back to black. Minus 810x. Does that make sense? So do each one separately and then combine, times them all together. So the next one, we're going to do 5(2). So 5c2, which is 10. 3 to the power of 3, 27. And then minus 2x squared, which is 4x. And now we're going to times that all together. So 10 times 27 times 27 times 4. 1080 x squared. Sorry, there should be a squared there. Okay, so can you try the next one? Try that term. Should have got minus 720x cubed. Okay, try the last two terms. So plus 240x to the power of 4, and then minus 32x to the power of 5. There you go. That is how you do, or how you make use of, binomial expansion. Okay, I have put up 2 questions. Let me find them there. I want you to use the binomial expansion to find the first 4 terms of each one, please. Okay, let's do 2a. Your method, your application of binomial expansion for the first 4 terms will look like this. There you go. And then the rest is just ... You don't care about the rest because they have asked you for the first 4 terms only. Okay, 1 to the power of 10 is just 1. 10(1), so 10c1 would give you 10. 1 to the power of 9 is just 1, and then x, so 10x. You're going to do that same thing. You're going to break down each one. The next one will be 45x squared, and then 120x cubed, and then blah, 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 because you don't care about the rest. Okay, next one. 2x plus y to the power of 6. Your a is equal to 2x, your b is equal to y, your n is equal to 6. When you apply your binomial, it's going to be 2x to the power of 6 plus 6, 1. 2x to the power of n minus 1, which is 5, and then times your b, y. 6, 2. 2x to the power of 4, y squared, and then one more, 6, 3. 2x to the power of 3, y cubed, and then blah, blah, blah. 2x to the power of 6 gives you 64x to the power of 6. The next one, NC1, 6C1 gives you 6. 2x to the power of 5 gives you 32x to the power of 5, and then you've just got y. So 6 times 32, 192, x to the power of 5, y. Okay, using that same process for the next one, 240, x to the power of 4, y squared, and then 160, x cubed, y cubed, and then blah, blah, blah. But there you go. That is how you use the binomial expansion.